Alright guys, I wanted to show you how to do stoichiometry with gases. If you take your mole map out, you can see that there's a spot for volume of gases. So this only works for gases. In this part of the transition, you're going to be dealing with the fact that 1 mole of any gas, if it's at STP, doesn't matter what kind of gas it is, it'll be taking up a volume of 22.4 liters. And if the gas is at SRC, so this is STP, and that's 0 degrees Celsius, 1 atmosphere. If it's at SRC, which is standard room conditions, this is a little bit more reasonable temperature, that's 25 degrees Celsius and 1 atmosphere still. So then the volume at SRC is a little bit bigger. So we can use and write these as conversion factors and do this part of any stoichiometry problem. So I wanted to show you two examples that are related to the worksheet that you're going to do. So this is one of them, and they want to know how many liters of hydrogen are made at room conditions. So I'm going to be ending here, and I'm going to know that I'm using SRC. So they didn't say SRC, but they said room conditions. I'm starting with grams, 16.7 grams of aluminum. So aluminum and hydrogen. So just like I've done in the past, I'm going to start with what I've been given, the 16.7 grams of aluminum. I'm always going to convert to mole using molar mass. So 26.98 on the periodic table for every 1 mole. Then I'm going to be in here, I'm going to do my mole-mole from the balanced equation. Let me move this out of there. So when I do that, mole-mole, I want to put 2 moles of aluminum on the bottom to get rid of my moles of aluminum, 3 moles of hydrogen. And then from there, you could do anything. You could stop at moles, you could go to molecules, grams, anything. But in this case, they want to know liters. So I'm going to go down here, and I know that 1 mole of any gas, but in this case, hydrogen, has a volume of 24.5 liters at SRC. So you can see that everything works. And we end up with liters of hydrogen, which is what they wanted. And then when I do this, the math, I end up with 22.4 liters. So let me show you one more problem. So here's another problem. In this problem, they want to know liters of water. So we're going to end up down here again at STP. So we'll be using 22.4. And we're going to be starting with 67.2 liters of hydrogen at SRC. So when I do this, I'm going to start with my hydrogen over 1. And then I know that 1 mole of hydrogen, or any gas, at SRC is going to be a volume of 24.5 liters. So that got me right there. Now I'm going to do mole-mole. I'm going to put my 3 moles of hydrogen down here. And then I'm converting to water. These all have to be gases to be able to use these values. And water is a gas if you look up above. And then lastly, now we want to know the liters of water at STP. So we're going to use 22.4 liters of water, or any gas. That's how much volume 1 mole of any gas at STP will take up. So again, you can see fun canceling, and we end up with 61.4 liters of water. So I hope that helps as you do your worksheet on stoichiometry with gases.